Good afternoon. ALCTS, the Association for Library Collections and Technical Services, is a division of the American Library Association. Today we are presenting Preparing for the Worst, Disaster Planning for High-Density Storage. We're delighted to have Roberta Pilette and Jennifer Hain Teper, speaking. Their full bios are on the ALCTS website, but Roberta is presently Director of Preservation at Yale. She previously worked at the head of conservation labs at Columbia, the New York Historical Society. She taught classes at the University of Texas Preservation and Conservation Studies Lab, and she also co-edited Preservation on Issues in Planning. That's a journal. Jennifer is the head of conservation of the conservation unit at the University of Illinois Urbana. She is also interim head of preservation. She worked at the Harry Ransom Humanities Research Center as well as the University of Pittsburgh, the New York Botanic Gardens Library, that sounds like a great job, and the University of Kentucky Audiovisual Archives. Her experience comes from disaster recovery events including several floods, pipe bursts, and large mold outbreaks. Today the program is going to concentrate on current research in disasters, including fire protection as well as water and fire-related disasters. So without further ado, we'd like to go ahead and welcome Roberta.
Hi. I believe that you will be having a poll. Are we putting the poll up? Yeah, so I'm going to give a little bit of background while everyone is answering the poll question to the project that I'm going to be talking about. So about 7 years ago at Midwinter ALA, the ALCTS Preservation Administrators Discussion Group held a panel discussion on emergency preparation for high-density facilities. And the panel consisted of Tom Schneider, who was then at Harvard Storage Facility, and Janet Gertz from Columbia. And she was talking about the RECAP facility, which is shared by Columbia, Princeton, and New York Public Library. So Tom and Janet talked about the challenges of protecting materials in these types of facilities. And then there was a third panelist, Tom Gately from Copper Harbor, who's a risk management consultant, and he was part of that panel also. So that was sort of the basis that kind of set off alarms after the presentation, and I'll talk a little bit about why. How are we doing with the poll? We're closing it. Okay, so my screen, can people see that yet? I need to have my screen. Show my screen.
We can see you.
You can see it. Okay, great. So Tom did a presentation at that panel discussion about fire suppression systems in warehouse facilities on which the high bay library facilities are based. The photo on the right shows an aisle from such a facility. He showed a video of a test burn for a warehouse type building conducted by FM Global, and FM Global is who we worked with, but FM Global is one of the largest commercial and industrial property insurance and risk management companies in the world, and they are a leader in property loss prevention through their own ongoing research and development departments, which are pretty amazing. But Tom pointed out that the fire suppression systems used in these library facilities were essentially designed for warehouses, not the storage of library materials. So where's my move forward? There we go. And I wanted to talk about some of the differences, and while the exteriors of these facilities may look alike, the interiors are another story. There are three key differences between warehouses and high-density library facilities and the interior, and one, they're listed here. The two that I really want to stress is the solid shelves and their spacing, and the narrow aisles due to the size of the materials being retrieved, which are books. We don't need huge aisles. And these photos really show the difference between the two interior spaces. On the left, you can see we have very homogeneous collections of mostly paper-based material that require long-term storage. And on the right, there's a warehouse with pallets of whatever material, and it's ever-changing. It's not going to be there all that long necessarily. So immediately following the panel discussions at ALA, a number of the preservation librarians got together and wondered, what could we do to address some of these significant differences and the risks that they may present? Well, at ALA, things don't always move so quickly. So in June, so 6 months later, we got together and tried to figure out where do we go from here, and we decided to contact Tom Gately, who then suggested two things. First, contact FM Global, and second, determine an approach. And I've listed the folks that have been involved in this essentially informal consortium since that June meeting. Now, FM Global turned out to be the insurer of some of the institutions listed, and they were interested in seeing where these questions, where our questions about, well, what should we do, may lead. So in the spring of 2006, David Fuller from FM's Engineering Hazardous Group became our main contact and began to contribute to the development of the project. Dave agreed with Tom in that we needed to do research based on a typical high bay, high density facility. And in order to do that, a survey. So with Tom and Dave's help, our first step was to design and send out a fairly detailed survey. We ended up with a return rate of 51%, which is pretty good. The slide here gives some idea of the general categories of the questions that were asked. And in fact, some of the institutions who are represented here at the webinar, attending the webinar, may have actually participated. The survey also included questions regarding what was stored and how. This information was then used to create the mock scaled facility at FM Global that was used in the various tests. The slides that I'm showing here are actual facility slides. Later on, I have some pictures that were provided by FM Global. So the survey also asked about what was stored in the module and how, as well as the sprinkler head arrays. And I've got pictures here of what is called in-rack sprinkler heads. And I'll talk a little bit more about what that means by in-rack. But I want to talk about what our timeline was. So the survey, with the survey in hand, we all met to see what our next steps would be and explore the viability of the project for, and that meeting was in July 2006. In May 2007, we heard that FM Global had approved the project and Dave Fuller was officially on the project, and we now had a research engineer, Kristen Jamison. So it took almost a year for the project to be sort of articulated and then presented to the FM Global higher-ups who would approve the cost involved with all these tests. And I want to stress that FM Global took on the entire cost of all these tests. In February 2008, the consortium members got an update after the first set of tests and to reaffirm what our goals were. And then March 2010, the tests were complete and there were some preliminary results and recommendations. But before I get into all that, I do want to talk about what the goals of the project were. So we wanted to know what were the fire protection options for this type of facility. We knew what most facilities had, but we wanted to know, was that good enough and what happens if we changed it? We also needed to control the degree of damage. We wanted to lose as little materials as possible. We all agreed that wet material was not necessarily lost material. This was sort of a revelation for FM Global. They were concerned also about how much got wet. So were we, but they didn't realize that we felt that wet material was recoverable. Then we wanted to know what to do in order to have the best possible protection in new facilities. So before I get to the test results, I want to clarify terminology and the test shelving array. So if we're looking down from the top, sort of at the ceiling, at our shelving setup, you see one aisle, which is here, and and then back-to-back shelving units. Now, each shelving unit, this is called a rack. And then these spaces between the racks are called flues. So the flue that runs parallel to the aisle is the longitudinal flue, and this is the transverse flue. The test array consisted of 12 racks, which is outlined here in green. And the shelving was a space-saver shelving designed for high-density library facilities, and it was built to 20 feet high. Most of our facilities are at least 30, and quite a few are 40, but they felt 20 feet would give them accurate test results. So there were 3 separate tests that were run. The first one showed the in-rack sprinklers, and there's a picture here of the in-rack sprinkler. And they were at levels 10 foot and 19 feet. And then there was also ceiling sprinklers, and these had books in trays on shelves. Test number 2 had essentially the same setup, but they mixed what was on the shelf. It was books and trays plus archival boxes on shelves. Excuse me. The third test was the sprinklers were the same, but they added face sprinklers, and I want to show you what those were. These were the in-rack sprinklers, and actually there was a sprinkler at each intersection. What they did for the third test is they added at the same level, the 10-foot and the 19-foot level, what they call face sprinklers along right in front of the shelving units. So that was the big difference between the first one and the third one. They also had a mix of the books and archival boxes on the shelves. So the results. Early detection means faster reaction and less damage. So smoke detectors are a given, and their tests all had smoke detectors. And that made, they considered that the first line of defense. Then the next one was the in-rack and the ceiling. They decided provided good protection. But the best was by adding face sprinklers. And what they found was there was 50% less damage due to fire being extinguished faster, thereby limiting fire damage and less water being expended. So you were also limiting your water damage. Along the way, there were other things that came to light. All of the facilities have fairly narrow aisles. Most of the aisles range from 46 inches to 54 inches. The test aisle was 48 inches. The length of the aisles for most ranged from 190 feet to 215 feet. So you could imagine fire in the middle of a 200-foot aisle is pretty difficult to get at. And we have to remember that the fire sprinkler system is designed to suppress the fire. It is not designed to put out the fire. It is the fire department that puts out the fire. So we need to keep all of this in mind, and also just thinking about how much material is in just one of those racks. One rack at the 40-foot height is about 400 linear feet, or maybe 4,000 volumes. So you could imagine just involving 2 or 3 racks, you're going to have thousands and thousands of books. These slides are from some of the FM Global tests. I know they're a little bit surprising. I'm not sure how many minutes this is into the test burn, but every test burn used the same ignition material. What you're seeing is this was from the burn right in front of this area here. These are books that have swollen and fallen off the shelves. So besides the fire and the damage, we have to consider the firefighting in the narrow aisles. We have to consider the swollen books that could not be restrained because the books are stored in trays, cardboard trays. The trays fail and the books expand and they fall off the shelf. So there's a number of things that came to light along with just trying to find out what's the best array for the fire suppression systems. As I said, the cardboard trays failed pretty quickly, and so we're looking at what some of the other options might be. In fact, FM Global encouraged finding another material for the trays, and we did put out an RFI to see if we could find an alternative material or a different way of constructing them. And at this point, we've gotten some test results, though they haven't really published any formal test results. But the upshot is that cardboard just doesn't work. Whether it's coated or uncoated, it doesn't matter. The coated board lasted about 30 minutes, but if you think about it, in an emergency of this size, it may be hours or perhaps even days before you gain access to the area, so 30 minutes isn't going to make a whole lot of difference with this. The covered trays, which you see here, basically help water not coming in and making this into a little bathtub, but there's still water that's being absorbed from the bottom, and ultimately they do fail. So, final recommendations. Smoke detectors are definitely a good idea. The in-rack and ceiling sprinklers are good, but the best is adding a face sprinkler if at all possible. The local fire department needs to be familiar with the facility, and remember that the narrow, long aisles can seriously inhibit fire extinguishing, as firefighters will not be able to get a good angle on the fire. Books falling from the shelves will block the aisle, inhibiting recovery, as well as books falling from the shelves can be a serious physical hazard to recovery staff. In tests, the books were falling from the shelves as much as 4 hours after the fire was extinguished. And finally, we need to think about ways to keep swelling books from leaping to their deaths. A new tray, material, or shelf restraining system may be worth considering, especially for new facilities using this model of storage. And finally, I want to thank the FM Global folks. All the testing was fully funded by them, as I pointed out. Anyone interested in receiving a copy of the report, which has now been completed, should contact David Fuller, and I've given his email here. It would be helpful if in the subject line you would put fire protection, high density library storage. That at least lets him know what you're asking for. I'd also like to thank the fellow consortium members, and that's Janet Gertz, Jane Hedberg, Tom Schneider, Jan Merrill Oldham, Sherry Burns, Jeannie Drews, Shannon Zachary, and Tom Teper. So any questions that would be happy to answer.
Okay, so I'm going to go ahead and get started now. And what I want to talk about is, this is Jennifer Hain Teper, sorry, talk about some testing that we did here at the U of I. We have a slightly different setup. While we were certainly partnering with the work that FM Global and Yale was doing, we also had a slightly different setup over here in that we don't have in-rack sprinklers, and we did have the ceiling sprinklers, but as opposed to the majority that Bobby was addressing that said that the suppression was really, the fire suppression system was meant to suppress the fire until the fire department got there and put it out. We actually have installed a deluge system, and we're probably not the only place that has that or is considering that as a sprinkler option. So we did some testing of our own in this area. Just an overview of our facility. Basically, we've been open since 2006 and have just opened our third vault. The first two vaults are the typical Harvard model, like Bobby was talking about, but the third vault actually has mobile high bay shelving. And so we have many, many millions of volumes capacity out here, and obviously are very vested in thinking about disaster recovery if something were to strike our building. So the things that basically made us think about disaster recovery and why this was important was that this really required a unique approach. And so we were trying to look at how to design an overall disaster recovery protocol. How can we move these masses of materials? This is on a scale that we had not even considered for conventional disaster recovery. What types of disasters do we need to plan for? How are we going to identify materials of high priority in this sort of storage? Because our first vault actually had integrated special collections and non-special collections materials scattered throughout the vault, which made identification of those materials and prioritized salvage really difficult. And there we go. So basically what we did was to partner for the answers to some of these questions with our engineering program, the Industrial Enterprise Systems Engineering Program, which actually has a small force fee service that we can hire either seniors or graduate students in the program to help us think about logistical issues of workflow management and whatnot. And so we saw this as an opportunity to bring some engineering brains to this, and it was actually proved very, very helpful. What we needed to do was first to have them gather some statistical data to look at what our losses could potentially be in this space, to help us really wrap our heads around what are the potential types of disasters that may strike us, what are the possibilities of those, and what kind of losses will we be facing. We hope that they might be able to recommend some facility improvements to be able to reduce our risks in this facility, and then also to lead us to our first steps in proposing a disaster recovery plan, looking mostly at the retrieval and recovery options. One of the first things that the engineering students did was then to do some water movement modeling. And what they did was to look at the placement of our sprinkler heads and look at the placement of our shelving, and then use this modeling software to try to figure out what sort of water flow and then concomitant damage would we be able to expect from basically a worst-case scenario disaster where, well, of course, worst-case scenario would be fire, and the fire engulfing the entire facility. But assuming that the sprinkler heads go off and do their job, what kind of a situation should we expect as far as water damage is concerned? And they did place that as the worst possible case scenario of a sprinkler head directly over our materials, not the places where the books are located in between sprinkler heads, but we were actually testing one that would have been directly beneath a sprinkler head. We actually did end up doing a live test on this using the same sprinkler head that we have installed in our facility, as well as a 5-foot by 3-foot by 3-foot section of shelving. We used realistic positioning of shelf heights. We used discard material that were all trayed up, very similar to what FM Global did, but on a slightly smaller scale. And then basically we talked with our Fire Services Institute to try to understand what a realistic sprinkler time would be for us to test, and they anticipated that 30 minutes would be a fairly realistic time from the time that the sprinkler head would go off until the fire department were to be able to get to our facility, assess the situation, and shut down the sprinklers. And so that was the time that we decided, the duration that we tested for. We then actually decided that we were going to track the damage and the weights of materials before and after the water test to see how much water was being absorbed by materials, as well as the observable physical damage that was incurred. So this is a picture of the water modeling that we did, and you can see the cascade effect, basically, that water pools on the top few shelves and then obviously is reduced in the amount of water that's spraying down as it goes down, which is exactly what we expected. And this is a picture of our first test. And basically what we did here was we were tracking the absorption of the water and the expansion of materials, and using that information then to inform us about possibly changing our types of trays, changing our placement of materials, etc. After the end of test 1, we actually decided that we should run a second test. And that second test was needed because we realized that we were getting some very disparate information from more archival materials, so things in like cubic foot boxes, and then we hadn't tested what happened with flat files, and we had just opened a second vault at that point that had a bunch of flat file storage in it. So we were really curious about how different types of materials might react in this environment as opposed to just the trade books. And so this is the setup for our first test, which is a front and a side view. What we have here are some cubic foot boxes located up here on the top. Oops, that's not what I meant to do. Sorry, I accidentally clicked. We have some trade versions, and you'll notice that in our test we actually have 2 different colored trays. And the reason behind that is because we had originally planned on having our special collections trays differing from our general collections trays, and having our special collections trays be buffered, lignin-free, higher quality preservation quality board. And so we wanted to test how those 2 trays actually reacted and whether or not there was a difference between the 2 trays. We then had some large flat trays that held microfilm, as well as some wrapped newspapers, which is the way that we actually store our unbound newspapers in HD storage. And this is just a side view of those same materials. We then turned on the sprinkler, which ran for 30 minutes, and I hope these pictures convey the amount of water that this sprinkler head put off. Again, this was a higher rate sprinkler. It had a larger orifice than most suppression sprinkler heads. This is considered a deluge head. But you can actually see the water literally running off in a giant, almost waterfall off the back of the shelf, which, as Bobby explained, the setup for these shelves would be then going down one of those flues and then damaging the materials behind it. And we did have, as you can see over here, a shelf that was actually braced to the back to sort of mimic that flue setup and to get an idea of what kind of damage we might see on the opposite side from that sheeting reaction with the water. So basically, in a nutshell, what we saw was that in general we saw weight increases. We saw a fair amount of dimensional expansion. The dimensional expansion average was 17%. Obviously that was dependent upon location. It was higher or lower. Certainly we saw materials with enclosures like boxes showing less weight increase from water absorption than those without enclosures. Generally the front trays held a lot more water than the back trays, which makes sense because the water was traveling down the front of the shelving, not so much over the back. And this is just a graphical representation of the weight distribution and the water gain. And the disparate one that's poking out here as the anomaly is newspapers, which we found because they were large and flat sitting on the shelf, not upright, and generally just basically sponges. The paper that newspaper is made of is so hygroscopic or water absorptive that those, even though they were at a lower shelf level, actually did absorb disproportionate amounts of water. But in general, we saw exactly what we expected, which is that the shelves nearest the top absorbed more water, and generally it trended downwards. We, just like the FM Global study, did see books leaping to their death, a much smaller quantity here because we had a much smaller test, of course, but we did see massive amounts of box failure. And that was very disheartening and something that in our plan we're going to have to deal with how we're going to approach clearing books now from the aisleways and what sort of safety precautions we'll need to take for that. One thing that we weren't quite prepared for, but once we saw it totally made sense, is that the barcode labels on the box actually sheeted off with the abrasive action of the water. They pulped up as they got wet, and then as they got more and more wet, they actually started to delaminate and peel off. These barcodes on the boxes are actually a critical step in the identification of placement of materials and inventory tracking in these facilities. And so this was very, very concerning to us because they were one of the key elements in us being able to track the movement of materials if we were to try to extract these from the facility. Even if the trays were physically damaged, we had initially planned on having those barcodes and being able to, at the very least, either scan them in or cut them out or in other ways somehow salvage them to keep them with the materials that were localized to that tray area to help with inventory tracking. But obviously these barcodes are completely unreadable, so that was a concern that we definitely have to deal with. You can see in these pictures just the awesome power of a sprinkler head for 30 minutes. Not only the aggressive downwashing of the water and the force of that water actually deforming these text blocks, abrading those labels, swelling the boxes, completely abrading what is quite heavy, good quality paper off of our newspapers and completely pulping that paper. But in addition, literally pulping some text blocks of poor quality paper and turning those books into mush. So that was obviously very concerning to us. Just some pictures of box failure. What we did find is that the archival quality boxes actually pulped and failed quite a bit faster than the more general just cardboard quality boxes. And this has actually made us decide to completely rethink what types of boxes we were using for special collections, especially relative to the very good preservation environment that this HD storage environment offers. In our second test, we went ahead, as I said, ran basically the same test. This time it was outside because it was nice, so we didn't have to hold it inside a room. But tried to mix up the materials a little bit more, adding those flat files, adding much more archival quality material. And one of the other reasons that we wanted to run this test was to test our own recovery mechanisms to be able to go through staged archival boxes to pull out at-risk materials prior to freezing and basically do a time trial for our recovery efforts. Because for those of you who aren't familiar with this, there's a lot of audiovisual material that really shouldn't be frozen, but freezing is obviously one of the biggest and quickest tools that we're going to have at our disposal in dealing with a water disaster in one of these facilities. Just a couple pictures of the test number 2, and again, that massive amount of water sheeting off the back and just beating books down out of a tray. With these materials being more mixed materials as opposed to straightforward trade materials, we saw an overall weight increase of 45%, which is fairly in line with the first test of materials without enclosures. With enclosures, we actually saw an 85% increase. The swell was roughly similar. Unfortunately, our flat file data ended up having to be discarded, which was one of the main reasons we really wanted to pursue this second test, because the pipe that we were using and joining together to be able to attach to the sprinkler head to run this test ended up springing a leak about halfway through the test, which sprayed directly onto the flat files. So our flat files were really, really wet, but we weren't sure whether or not that was because of the overhead action of the sprinkler head or whether that was really more due to this leaking pipe juncture that we had. So that's unfortunate. Resulting damage, again, was very similar. These special collections boxes were actually the plastic-coated cardboard trays, which we had hoped would actually make a difference, but it did not. Those trays did still fail pretty rapidly. You can see the swelling out the back into the flue, as well as the swelling out into the front, and then the materials actually falling onto the floor surface. You can see the pooling of the water on the shelves, which Bobby was pointing out that, obviously we're concerned about the bathtub effect of the boxes, that the water pours into the box and then sits there. But even if the box is reasonably tight, or those covered options, that the pooling of the water on the shelves and the wicking of the water up into the boxes is still enough to be of concern and to frequently compromise the boxes. You can see here, for those of you who are preservation folks, an indicative little discoloration there of the very poor quality of the archival boxes that we were using for this test. These were some of our really old box stock and some discarded records that we had that were due for records destruction. But what we did find out was that these boxes, unfortunately, are very, very common, and they were glued together. And at least for this era of glued together cubic foot box, we found that the adhesives actually failed on those boxes after only a 30-minute exposure to water and then an immediate salvage. So as Bobby pointed out, in some cases we're not going to be able to get to these materials for hours or possibly even days. And we had complete adhesive failure on these boxes within relative minutes, which was really disheartening and frightening, because these were now very, very unhandleable and posed a lot of issues with salvage. So another issue, after we looked at all of this and kind of were able to better wrap our heads around what to expect as far as the situation that would present itself in a major water disaster when we entered the space, what we also wanted to think about was identification of materials. Now, as I said, originally we had planned to do special collections in these different colored boxes and these different colored trays, and had thought that, well, part of it is we would just be able to do visual identification fairly quickly. But when you're looking at millions of items and thousands of trays, visual inspection and observation really wasn't going to facilitate a speedy recovery. And as we looked at, obviously, the failure rate of these special collections trays, we also realized that we were going to have to, it would be best suited to move our special collections into the more general collections trays, and therefore we wouldn't even be able to rely on that. So one thing that we did for our first module, which had already been populated with materials and special collections was already scattered throughout the collection, was to basically have them create a greedy algorithm to locate the dispersed special collections materials and to map them for us, and to locate the areas in the vault that had the highest concentrations of special collections materials so that we could look at these. And this particular screenshot that you're looking at right now is actually just of one aisle. And so we can see in this one particular aisle then where the areas are in that aisle that have the highest concentration of special collections materials versus those that actually have very few. So that once we know the area of the disaster, assuming that only a few number of sprinkler heads have gone off, then we can actually prioritize our recovery in the areas of the highest concentration, which is just a smart way to go about that. I will say that in our second module and subsequent modules after that, we actually have requested / required that special collections materials actually remain all in hand recoverable spaces. And while they are still integrated somewhat with general collections, none of them are above about an 8-foot height, so that in the event of a disaster, we are not requiring the use of lifts or of cherry pickers to be able to extract high priority special collections materials, but instead could just basically send a swarm of people down an aisle and pull that material out very quickly, which is exactly what I just said. And the fact that we are recommending to use the similar trays. Sorry, I was getting ahead of myself. But I will say that we are still going to be identifying special collections materials even though we're using the same tray, simply again for that necessity of recovering materials quickly, that we want to ensure that we know which ones are special collections. And so we actually are using a sheer sort of label saver thing over the top of the barcodes, reasoning being not only is that going to color code our special collections trays so they're visually identifiable very quickly, but we're also hoping that that will, it doesn't save that sheeting and destruction of the barcode on the box, but it hopefully will reduce it a little bit if we have some sort of label saver over top of it to reduce the immediate effects of water. We still found that they did peel off the box eventually, but it prolonged that, and at least they weren't immediately destroyed. So what this means for the future? Well, basically we have just finished constructing our Vault 3 with the potential of construction of Vault 4. We have a current disaster plan now which really functions fairly well, at least theoretically, for Vaults 1 and 2, and a plan for how we would recover it. We have actually gone through several meetings and are planning a tabletop exercise to walk the entire disaster team through mock disaster recovery, and I feel like while not all the questions are answered, and we still certainly do have a few holes in this, we do feel that we've got a reasonably good handle and have certainly been thinking about this and are as prepared as we reasonably can be with the amount of unknowns that this sort of situation presents. But just to muddy the waters, we've now opened up our third module, which has mobile high bay shelving, which is 35-foot tall shelving that is running on motored rails and actually collapses much like standard compact shelving that most libraries are familiar with. This complicates matters considerably, and I will admit that we haven't really addressed how this is going to change our disaster recovery protocols now that we're working in a mobile high bay environment. But it is going to change our ability to do things like drive forklifts back multiple aisles at one time, or have hand extraction going on in one aisle while another aisle is being opened for the taller recovery. We're really going to be forced to look at an aisle-by-aisle recovery, which could really slow things down considerably. So it is changing. It's also going to change the way we want to prioritize our actions, because we are, again, able only to have one aisle open at a time. So we want to make sure that we're properly approaching the prioritization there and balancing the destructive nature of the disaster and those areas hardest hit, again with those areas of highest priority for recovery. So for us, I did want to make sure that we thanked the Illinois Fire Services Institute. They were very, very helpful in us helping us think about the sprinkler setup and different options, as well as assisting us with all of our testing setups. The IESI program students who were very, very valuable in helping us to address some of the more engineering and statistical type attributes of this. We happen to also have an Academy for Fire Sprinkler Technology here in town, and Cecil Bilbo, who's the director of that program, was very helpful in us thinking about different approaches to this, and then obviously the folks around the University of Illinois Library. So with that, Bobby and I wanted to be sure that we had plenty of time for questions and answers for you all. So I think we've managed to leave a little over 15 minutes, hopefully, and hope that you guys will have lots of questions. And I do see a few here that I haven't managed to look at yet. So I think we'll just go ahead and start with questions and answers. And I don't know, Bobby, if you want to go ahead.
Yeah, I'm trying to look at the questions. I'm not actually. Can somebody?
We've got two of them so far.
I see something about shrink wrap materials directly on the shelf. If plastics cannot be on the shelf, what sorts of materials are folks thinking of for making a new type of tray? I'm not sure. The whole shrink wrap question for offsite storage or high-density storage, I've heard varying things. I had actually looked into it at one point and talked with the folks who produced the shrink wrap and talked about the fire hazard and whatnot. They did not see, as long as there was, if there was not a flame source, in other words, if the flame source was removed, it went out kind of thing. So they did not consider it a fire hazard. So if that's where it's coming from, the plastic question is coming from, I don't think that they sort of relate. We did look into the question of plastics for the trays, but we didn't want them, not because of the burning, but because of the melting. We just didn't want to have to deal with the sort of the mess, as it were, of the melting. We also were concerned about, depending upon what plastic you were using, what was being given off in the burning. So,
and there's also the issue of cost. I mean, a lot of the better quality plastics that we would look at for long-term storage are really expensive compared to cardboard.
Yes,
and most of us cannot possibly afford that kind of cost.
Well, I will say that the whole tray question has been looked at in a variety of different ways, and if people have other ideas, certainly be welcome to contribute those. FM Global had actually recommended that we go to some sort of a metal or a metal basket of some sort, which would be great. But again, it's the cost. The cost of anything other than sort of the basic cardboard, it just gets to be pretty, it's a major part of not going that direction.
Right. And I would just add that another concern about shrink wrapping that I don't know if you'd heard, Bobby, but was something that we had certainly heard, was that for fire suppression that it was recommended that we not have shrink wrap materials in HD storage, because that then eliminates the possibility of pre-wetting materials in a fire situation. And the whole idea is that the whole purpose of sprinklers is to dampen materials so they don't catch fire, and if they're shrink wrapped, they're more burnable, and so there's a fire risk there.
Yeah. Right. That's a consideration also. If you're having a huge amount of it, that was it's like what's the tipping point kind of thing. If you're going to have trays and trays of shrink wrap, you probably do have some serious problems. Yeah.
Right. The next question is from Christy Short-Traxler from Bodleian. I was afraid someone was going to answer the question about the discharge rate of the deluge heads. I can certainly send that to Alex and make sure that they give you that information. I should have had that in a note in front of me, and I don't. And I don't remember the rate off the top of my head. I apologize, but I'll be sure that you all get that information. It's pretty high. It is a shocking amount of water, and the orifice on these is a good almost 1.5 inches across, which is about 3 times the size of a standard sprinkler head. So it's pretty high. I can't give you anything technical. I'll have to look it up. Don't make me explain exactly what a greedy algorithm is. That's why I didn't do it. But the engineering students are the ones who did this for you. We actually do have the math behind the construction of that algorithm available if people are interested in seeing it. If you're technically into that kind of thing, they're perfectly happy with us sharing the math behind the development of that algorithm and how they came to formulate it. So if people are interested, I'm happy to point you to that and to share that. As far as external salvage providers, We actually do have a standing contact with BMS Catastrophe. Most large libraries, of course, are probably going to have some sort of pre-existing contract with an external salvage provider. We did at least talk to BMS and let them know that we have this facility, and when we were constructing our disaster plan, we did actually loop them in, not so much as to say, here's our plan, here's what we're doing, but to make sure that our expectations of them were in line with what they were prepared to be able to provide. Because again, on this sort of scale, we weren't sure, how many freezer trucks can you send? What sort of inventory control are you going to be able to provide us so that we're not overlapping responsibilities and doing double work, or there's a gap somewhere where we're losing materials. So we did talk with them just about our expectations and making sure that our expectations of their services were realistic. I don't know, Bobby, if you have anything to add to that one.
Yeah, we've been using Munter. We had a major problem here a number of years ago, and so we've had experience with large recovery efforts, but not in a high-density facility. But we're also in the midst of really looking at our emergency planning for LSF, and we plan. What I found out is we have sort of an agreement with Munters. We have no formal contract. So what we want to do is put together sort of an RFP and really go out and look and see what we can get a formal contract and really bring people in so they understand what the facility is and what our needs are, and it's as clear as you can get it given the amount of unknowns in the situation. So the next question was Andrew Robb is asking if any thoughts with use of lifts when water is present on floor and or shelves. Jennifer, I don't know if you were in on the conversation, but Harvard had done some research on this, and they discovered that you needed to have a certain type of tire on your lift in order to be able to move on, get traction on the wet floors. So do you remember what one? Was it like the true rubber rather than the
I'd have to look it up. I don't remember off the top of my head.
There is definitely something that you need to be aware of. So unfortunately, we can't give you the right information at the moment, but yes, that is something to be concerned about.
And I'm not sure, Andrew, what the concern would be with the lifts and the shelves, other than just the possibility of splashing water onto machinery and whatnot. So I'm not, I mean, the water on the floor is definitely a concern, and we did, now that we're looking at future construction of facilities with our third module and some of the knowledge that we now had, we were sure that we had peripheral floor drains, because one of the issues is a lot of these operate on super flat floors. And you can't have floor drains on super flat floors. Because you need to have an effective floor drain, your floor needs to slope towards the drain. And so you can't do that. So what we did in our third module to at least aid in the movement of water was to create peripheral floor drains around the edges so that at the very least we could basically go in and start squeegeeing water towards the edges, so there was somewhere for it to go and to drain, but it couldn't be placed inside the aisles themselves. But we did think about how to at least be able to move water to get those floors dry as quickly as possible. Andrew Hart asks, Jennifer, where are the sprinklers placed in both stationary and high bay shelving in Illinois? They are all on the ceiling. They're scattered throughout. They're not placed directly over each shelving bay, which I do not understand for the life of me, but I am not a fire suppression professional, and the people who designed it swear that's the appropriate placement for the massive materials and the distribution of sprinkler heads, et cetera, et cetera, et cetera. We actually did look at doing in-rack sprinklers for the third module with the mobile shelving. But in the end, although despite the data from the FF Global report, people were awfully nervous about having, basically it would have to be hinged fire suppression piping to be able to function in-rack in the mobile shelves. And so opted again for these deluge heads overhead. But I can't tell you, exact placement as far as how far they are apart, except that there is not one per aisle equivalent. They're actually more like one every aisle and a half. Vasu Yengar asks, how do we recover rare books in our vault in case of flood? Well, that's a big question. I mean, for us, it was really the only difference between how we're going to recover rare books in high density storage versus how would we recover rare books in any other type of water or fire disaster is really just how quickly can we get them out was our biggest concern. Beyond that, once they're out of the facility and in your hands, the recovery is going to be the same for rare books, whether you're in high density storage facility or whether you're in any other sort of library situation, and it's going to depend on the type of rare book. Obviously, vellum and parchment are going to have very different reactions to a water disaster than, say, a paperback that happens to be in the collection. And then it's really up to your library to look at what sort of recovery do you have. I would say that our number one reaction for recovery of a water disaster in one of these sorts of environments is that we're just planning on freezing as much as we possibly can, and that's going to include a lot of special collections. We want to get the fresh special collections out and frozen first to reduce the risk of mold and of building water damage. But for the vast majority of it, we're going to consider freezing to be our first line of defense for pretty much everything, unless we have the luxury of doing some selective removal of materials that aren't appropriate for freezing. I don't know, Bobby, if you have anything to add to that one.
No, I think that's pretty much it. I mean, what we're thinking about is how I view these emergency situations in these high-density facilities is it's either very, very small. In other words, there's a book truck filled with something that somebody, was parked in the wrong place or whatever, or you just have thousands and thousands of volumes. And the only thing to do is some really rude and crude, sorting, and with the idea that 99% of it's going to be frozen, and that will buy you time to then make decisions. Jen, I think the next one's yours too on the foil back labels.
We have not. We tried label savers first because basically the production of the labels for the tray labeling, we don't want to have to use different types of labels for different types of trays. And obviously, again, it gets to cost. The foil back labels are so much more pricey than the non-foil back labels. That it was just cost prohibitive, so we've kind of been experimenting with the label savers for at least special collections materials, and then trying to wrap our heads around other ways to identify, or what our big suggestion was let's double label them and actually label the back side of the box, because we're seeing much more of that water damage on the very front-facing edge of the shelf if we just label the back of the trays in addition. For those trays that are going in the front of the shelves, that should mitigate that. So that's kind of been our approach right now, as opposed to going with much more expensive labels. But foil back labels certainly are an option and something that we threw around but ended up not going with.
The next question is having to do with the fire heat damage for comparing high density to standard shelving. I know that was a concern with the FM Global test. They were initially in setting this up, they were worried about how the heat would affect the stability of the shelving. And part of their whole thing is keeping the heat down by the amount of water on the shelving. Mm-hmm. As to how it compares with standard shelving, I don't know. I would think it's the same sort of materials. It's the company is the same company that's making shelving for libraries in general. So, Jen, do you know anything?
The only thing I know is that we did ask Space Saver about how hot would it have to get to start bending or compromising the stability of those shelves.
Right.
And basically the heat necessary to begin to actually torque or compromise the shelves is far higher than any fire, as long as you've got at least some sort of suppression system in there. Mm-hmm. It would have to be a full-blown engulfing fire to actually begin to compromise the shelves. And at that point, your material's probably gone anyway.
I was going to say we have bigger problems then.
Yeah. But they have thought about it, and it is very heat-tolerant shelving.
Yeah. Do you know any real-life instances when high-density facility either caught fire or had the sprinklers go off? If so, what lessons were learned from the event? I do know of one instance where the sprinklers did go off in a small area, and basically what it was, it had to do with the trays. And this institution is using the covered trays that I showed in my slides, and they found that, first of all, it happened during the day, and it was noticed right away, and so it affected a very small area. But basically, the covers, as you would expect, had the water sort of shed off, and very little of the material inside got wet. So it was kind of you know, it's almost not real life, because if it had to happen, it happened under ideal circumstances in that it was immediately noticed and immediately taken care of. It really is from the tests just showing, I think the surprise to everyone was how catastrophically the trays failed. And, you know, trying to come up with, okay, now we got to come up with something else.
Right.
And then I see Tom's asking, or making a statement, Tom Schneider, who was involved in the beginning with this, says, presumably shrink wrap would melt to the surface of the volume in a fire situation. I would guess shrink wrap would protect from water damage. Yeah, I don't think that anyone, I don't know who's using a lot of shrink wrap in any of their facilities. I know some are. Are you, Jen?
No, we are not.
Yeah, we're not either. I know others are using it, but I don't know how extensively. Thoughts about water sensors?
I can touch on that one. That was certainly one of the recommendations from the engineering group that we worked with, was that we go ahead and install water sensors on the top of the shelves. They weren't as concerned about the floor because they were assuming that, you know, I mean, people are in these facilities every day. A puddle would be noticed reasonably quickly on the floor, but the problem is water possibly pooling up 40 feet above our heads. In the end, we ended up not going with that, not because it wasn't a good idea, but because of cost and maintenance. They would have to run you would have to place them so frequently on top of those shelves, because of course a water sensor is only good if the water drips directly on it. So you have to place them to be effective like every 6 inches if you want really good coverage of you know, where the water is before it's a big puddle. And the cost of running all those water sensors across and wiring all of them was just beyond the scope of what our project directors, when they were looking at construction, wanted to consider. I still think it's a really good idea. It was just an additional cost that they didn't think was worth, given the risk, that it wasn't worth it. But I perhaps don't agree with that. I don't know if you've given any thought to those.
No, we haven't used them, but yeah, you're right. Way up at the top, who knows what's going on. I'm getting the signal that we have one more question, and then the rest of the questions we can answer offline. So the question on tieback envelopes, no, it wasn't tested in either study, but I do know places, and RECAP is one of them, that is using tieback envelopes. Certainly the water is going to shed off of those a lot faster. I had talked with, again, I think 3M, who was making the tieback, about the fire concerns, and there was nothing there to be concerned about. So it'd be interesting to know how that would affect you know, the materials, as well as the whole concept of, you know, soaking something to help reduce the fire hazard kind of thing. And I think that's it. We have, or maybe we got. Oh, are we getting signals from anyone here?
Well, I'm no longer a presenter, so things are moving.
Okay.
But apparently we can answer all these questions offline. So we'll be sure, Bobby and I will take a look at these questions and certainly try to address all of them so you all can have it. And I'll look into some information in the previous questions for data about tires and sprinkler head discharge to be able to answer those as well.
Okay.
I'd like to thank Roberta and Jennifer for the presentation today. I know I learned a lot. All the attendees will receive the webinar materials as well as a survey that we hope that you'll take. It gives us some more information about plans for the future. The ALCTS Continuing Education Committee is always looking for webinar topics. We have a webinar every Wednesday and have to fill slots. So we hope you'll consider that, or either an idea or actually do a presentation yourself. There are forthcoming webinars listed on the ALCTS website. The ones in the near future include one on licensing, some digital preservation workflow ones. Our RDA webinars are always very popular. There's one in April on streaming video in multi-type libraries, and some on cooperative collection development. Again, I'd like to thank Bobby or Roberta and Jennifer, and this is their contact information. Thank you for attending the webinar today.